So, you got your MOMAT, periodic table, and a calculator. Let's begin. Now, remember, I want to start easy. So, how many moles are in 0.85 times 10 to the 24th power formula units?
Is that 2.85?
2.85 of calcium fluoride. Give me a second, let it get down. Just like always with these, find where you're starting, find where you're going. The dead giveaway for where you're starting is the number. Look at the units after it. This is my starting point. I'm starting at formula units, so I'm starting all the way over right. Find where you're trying to go. I'm trying to get to moles. So now, formulate a plan. Formula units. And I got moles. Can I go straight from formula units to moles?
Yep.
Yes, it's a straight shot. So, got a plan? Execute the plan. Take our number. 2.85 times 10 to the 24th formula units. Calcium fluoride. Set over 1. Just like before, if we're going to do this, we must have a conversion factor. So, we set up our conversion factor. Where am I trying to get to? So what goes in the top?
Mole.
1 mole. What goes in the bottom?
Avogadro's number.
Avogadro's number. Beautiful. It's 6.022 times 10 to the 23rd power formula units calcium fluoride. Hey, can I answer a question that some of you are probably dying to ask me right now? Will you get your mole map on the quiz? No! Now, I'll give you the periodic table. As soon as you get the periodic table, you can build a mole map. I will not stop you at that. But you will not get the mole map on your quiz. So formula units of calcium fluoride cancel. I'm left with moles of calcium fluoride. So, punch in the calculator.
Where did you get the mole calcium fluoride at?
That's what it is. I'm going from formula units of calcium fluoride, so it takes me to moles of calcium fluoride. So 2.85, second E, 24th power, I'm going to divide by 6.022, second E to the 23rd. I hit enter. Mr. Hoggett, 4.7326 moles of calcium fluoride. Pretty much, take it out 4 places past the decimal, pretty accurate, pretty precise, I'm good with it. Questions?
Okay, so you multiplied top number and then the Avogadro number. Right, I'm lost.
I divided.
You divided, okay.
When do you know to use avocado's number?
Whenever you're dealing with atoms, particles, molecules, formula units. So this is why I set these up the way I do. I first start with my number here and set it over 1, because then every conversion factor tells me what to do. This is in the top, this is in the bottom, so I divide. Now if there was something in the top, I'd multiply by it. Technically we are, but where this is 1 and it's multiplying, it's just the same number. Questions? I love the looks I'm getting as I look in the room. Okay. On to the next problem. All right. Let us try. What is the mass of 3.14 moles of choose something that's not that familiar to you guys.
Mercury.
Strontium it is.
Who?
Strontium. That's why I chose it, is because all of you right now go, what is that?
Where even is that?
Well, yeah, I got earth metals. I gave you Z, right? What does Z tell you? Atomic number, so now you know where the element is. It's 38. So, what is the mass? That's where I'm starting or stopping? Stopping, bless you. Where are we starting? Very nice. So what's the first step?
Set up your conversion factor.
That's the second step.
Set up your opposite of conversion factor.
More detail.
Figure out your chart.
Where you going?
Straight there.
3.0.
We did that.
3.14 moles over 1.
There we go. Set number 1. For those of you that are answering and you're not correct, please do not feel bad. You're giving me feedback and letting me know where we're at. What's the second step?
Set conversion factor.
Beautiful. So, you tell me what conversion factor we set up. You can use your mole math for help.
1 mole.
Why is it grams over mole?
Because he cheated.
I'm going 2 grams. Beautiful job. 2 grams of strontium. It's over 1 mole. What's the number to go with grams?
Avogadro's number.
No.
Molecular mass.
Yes, but no. That don't have a molecule. Just have an element. What is it?
Something from the periodic table.
Oh, I'll take that for now. We're,
Yeah.
you know, the train's in the station. We're looking at the park.
38. 38.
87.62. Where did we get that?
The average mass of the element.
The average atomic mass of strontium.
You know, Bill Gates, I think it's his name, has in his office, has this big, humongous thing, and it has each little element from the periodic table in it. I thought
That's
that was
cool. All right. So do I multiply or divide these two numbers? Multiply. They're both in the top.
But anytime you put, never mind, I know.
you should get 275.1268 grams of strontium. I'm giving you a second because I want to make sure you guys are okay. This is where we're going to slow. Yes, sir.
How come mold not on the top, not the bottom?
On this one? Because where are we going? I'm going to mass, and the mass will be on the top. Where am I leaving from? The moles. You got your mole map? So look at it like you're starting at moles, put your finger on moles. What arrow points back to mass? The conversion factor that's set with that, that's how your conversion factor should be set. So you should have the grams on top and moles on the bottom. If you like the mole map, use that. That's why the arrows point the way they do. Me, I'm not huge on the mole map. I like to look and say, I'm leaving moles, so I need moles to disappear. Moles have to go on bottom. I'm going to mass, so grams have to be on top. Either way works. There's people in this room that's going to like the mole map. There's people in this room that's not. It's up to you, your preference. Any questions from there? Okay.
Are these like examples of how the questions will be asked on the quiz?
Yes. And you will also get a practice sheet. So if at STP, what is the number of molecules in a balloon of a gas? Let's do it of a gas. Number of molecules of, I need a number.
4.
What molecules? I have to change that to B. So if at STP, what is the number of molecules of 784.3 cubic centimeters of methane? Help you out. Carbon, D is 6. Hydrogen, Z is 1. Now, here's the fun part. I want to teach you a trick. Formulate your plan first. Where are we starting? Volume. How do we know volume? Cubic centimeters is a unit of volume. Where are we stopping?
Molecules.
So molecules. So here's the question. Can I go from volume straight to molecules?
No.
No. What do I have to do first?
Go to mold.
I've got to go to moles first. Always remember, moles are going to show somewhere in your mole conversion. So we first go from volume to moles, then from moles to molecules. Question to you. First one, are we at STP to where we can do this calculation?
No. Yes.
Yes. How do you know that?
Because you just
Yeah.
said.
Because I told you in the problem. Second question, do I need the molecular mass of methane?
Yeah.
No.
No.
When do I need the molecular mass? When I'm trying to find the mass. I'm literally going to go from volume to moles. What number am I going to use to do that? 22.4 liters. Now I'm gonna go from moles to molecules. What number I use for that?
Avogadro.
Beautiful job. You didn't even look. If you did, I didn't see you do it. So I think you're getting it to memory. Avogadro's number.
So you always use 22.4?
When you're from volume to moles, or
Yeah.
moles to volume.
I thought that was an example.
So, let's work it. I have a question. Is there anything bothering you right now?
All of it.
Yeah, awesome.
More specific, is there anything bothering you in this problem?
You have to do a matrix conversion.
We gotta convert. What we gotta convert?
784.3.
Yeah, but it goes straight into,
So cubic centimeters, what are we gonna convert it into? So we're gonna convert that to liters? That's confusing.
No, we're not. We're going to convert to milliliters, but you just take that number, you scoot it over, then you turn that number and turn to liters.
no.
For me to go to milliliters, this will be a good review. You copy and paste the number. Some of you on your quiz did not copy and paste the entire number. You just copied and pasted the first bit of the number. If there's a number that's got this times 10 to something another, that needs to go with it. Okay? So 784.3 milliliters. All right, we good now? Can we do the conversion?
No,
Why not?
because you have to go to liters.
Got to go to liters. It has to be in liters. Remember, this is why Mr. Hall likes this trick. It's a trick in a trick. You catch the first trick, but can you catch the second trick? Very important. So we're looking at liters, 784.3 times 10 to something another. I'm starting at milli. What's the exponential? -3. Great job. You guys are doing wonderful. You better be studying your prefixes apparently. Minus liters, which is base units, so it's 0, which will equal -3. There's no exponent on there for me to multiply by, and I did not start with an exponential on my actual number, so there's nothing to add by. So it's just 784.3 times 10 to the -3rd liters. Now can I do a conversion?
Yeah.
Beautiful. Now, let's do the conversion. So I had 784.3 times 10 to the -3rd liters of methane. Yeah, I give you methane. All set over 1. All right, you tell me. Walk me through it.
Hold on, I gotta write it down. It's a big old number. You got to use Avogadro's number and put it over 1.
No, you don't
No,
use that
you
one,
put it
you use
over
the 22.4
On the
one.
bottom.
Well, I'm so glad y'all are listening.
So, set a conversion factor. What goes on top?
I cheese off the board.
1 mole of methane goes on the bottom.
22.4.
22.4 liters of methane. I want to pause for a second. If you have a question right now, now's the time to ask.
Where are you getting the 22.4 liters?
That is a number, that is an identity. At standard temperature and pressure, in 1 mole of gas, there's 22.4 liters of that gas.
Okay.
Yes.
Okay, so from volume to moles, whatever you're going to always goes on top.
Yes. If you follow this method, yes.
There's another method?
There is, but this one works best is why I like to do it.
Okay.
That's why you always take your number and you set it over 1. What you're going to goes on top. What you're leaving goes on the bottom so that where you're at will cancel. If you got another question, please ask me. I'm giving time now for you to ask.
I'm thinking.
You're okay. You're fine.
So, and And that works on any of them, right?
Yeah, every one. Every one. This is what I like
Whatever
to do.
number you start to convert, you put over 1,
Yes,
no matter where you start at.
exactly.
And then you convert it to whatever you go to, and then you put what you're going to on top.
Beautiful.
I think he just understood it without knowing he understood.
No, I'm just making sure that I know.
Yeah, you're okay. That's why I'm pausing right now, because I know there's a lot. I know this is throwing a lot at you, because you're having to take concept and math and marry them together and use them both.
Okay, and like the Avogadro's number and the 22.4, if you're not using that, then every other number that goes under is just gonna be 1 mole.
Yes, unless you're looking at mass, then you're gonna grab that information from the periodic table. Anything else? This is the quiet. This is weird. It's like, wow. Okay. Liters of methane on top, liters of methane on the bottom, they cancel. We want that to happen. I'm left with moles of methane. So I'm here now. Now I gotta get from moles to molecules. So, what I gotta do? Conversion factor. Are you talking about doing this right now?
No.
You can, and then take that new number and do the new property. That's fine if you want to do that. I like to run them all out. I want to check to make sure you were saying that, but you're totally fine if you want to do that. So, set it up. What's the conversion factor going to be here?
The top is Avogadro's number
Avogadro's number on top.
and 1 mole on the bottom.
What unit goes with Avogadro's number? How you know molecules? I gave it to you. Remember, don't freak out about that. Then 1 mole with methane on the bottom. Good job.
I have a question, just real quick. It's a real quick one. Do units matter in the answer, or do they matter as well as in the?
Ultimately, they matter in the answer, but whenever I go to do if you miss getting the correct answer, and I go back and I look at your math, the units help me.
Okay.
And remember, if you miss the correct answer, I'm always looking for partial credit. Some unit in there may help you. Now, I got moles of methane on top, moles of methane on the bottom. They cancel, leaves me with molecules of methane. That's where I'm looking to get. So, let's see what this equals. Here y'all, some of y'all already typed it.
I'm gonna go with the calculator, it takes me forever.
2.1085.
1 second, we'll check.
That's what I messed up.
2.1085 times 10 to the 22nd. Why'd you add that? It's a big number. If you forget the times 10 to the 22nd, that's wrong. Make sure that E there with that 22, that stuff has to be added with it. Remember, what's E stand for? Times
How
10.
did you put it in the calculator?
How did I?
Yes.
Yeah.
I did parentheses 784.3
Okay, so
E.
you do all 3 numbers.
I do it all together.
Okay, so you take the top one, and you're dividing by the other one because it's on the bottom,
Beautiful.
and then you multiply by the other one because it's on top.
Yes. Now, thing is, I put parentheses because where these have exponents, I end the parentheses so I make sure the calculator reads that
That's the wrong.
as an exponent.
That's the wrong answer.
Well, what's wrong with it?
You got big units on it.
Beautiful. molecules. CH4.
Well, you can blame me, I was asking a question.
No, I was gonna leave it like that. I wanted to see if you'd catch it.
Miss Cole says that.
I do, normally I'll do
We
this
like
too.
you.
I'll work something, put a wrong answer up there to see if you catch it.
What will Miss Cole?
But right now, y'all ain't ready for that, because y'all are so terrified right now if I made a mistake. Y'all would follow it blindly.
That is true.
When she messes up
I
on
keep
like
getting
just like
error.
simple basic math, she'll say, I'll just make sure y'all are awake.